Hello everyone, welcome back. So in this video we are going to understand about the Leetcode problem number 3827, count monobit integers. So I had tried this video to create before, but I found some misinformation, so I thought to update this video. Okay, so let's start to understand that we are given an integer, as we can see here, that is called n, and a number is called monobit, like here. Give me a second here. So a number is called monobit if all bits in the binary representation are same. Okay, that means all the binary string must be either all zeros or ones, you can say that. Okay, so if you represent anything, right, that comes with all zeros or ones, that is nothing but it becomes a monobit, right? The same type of bits is called monobits. Okay, so you must count how many such numbers lies in the range between 0 to n, that is we have to return. Okay, so very first we will understand what numbers are monobits, right, and then we'll go from further. So let me explain here. Very first, let's understand what is monobit integers here. Okay, so let's list them carefully. So can I say that if there is a case 1 when all having zeros bits, can we say that? So this is a 0 bit, we can say, if we have all, right? So let's suppose only one number satisfy in this case for 0. So if we have 0, it means how many bits will be there? 0 bits will be there, right? And in all other cases, let's call all are ones. Can we say that? So when all are ones, we can say that, and all are zeros, bits, you can say bits, this is bits s. Okay, so the case 1 is all are zeros and all are ones. So let's suppose what are the all are ones. So these number look like, let's suppose if we'll say 1, we can represent in 1. If we'll talk about the 3, we can represent all number are 3. If represent 7, all number become 7. If there is a 15, we can represent 1 1 1 and 1, like this. This 31, so we'll say 5 digit, we can say we have to take. Okay, means like that we have to keep going in the range. So mathematically these are the monotonic, we can say monobits, sorry, bits. And if we'll represent, so this is nothing but it become is what it will become like 2 to the power k minus 1, because we know 2 to the power is nothing but the sum value, right? Let's suppose it start from the 0, then it goes to 2 to the power 1 is nothing but 2, 2 to the power 2 is 4, 2 to the power 3, like that. So if you to take the minus 1, so it will come all the odd numbers that contains 1 1 1 1, right? Means there is only 2 cases when all are zeros and all are ones. Okay, so we should start with any number with zeros having, because 0 is always a monobit. So if you're taking any range, 0 will be the counted as a monobit. Then the rest of the thing, whatever the range you are taking, let's suppose you want to start from 2 to 15 16, let's suppose. So these will be the monotonic monobits integers, and there will be one more, so total will be 4, like that we can say that. So what I'm trying to say is, let's suppose we have n equal to 1, right? So the number in the range is 0 to 1, we can say. So 0 itself, as I told you, is a monobit because it's having only one bit for the zeros. If you talk about the 1, there is only one bit is there. So both are monotonic. So total count is how many? Is 2, right? So 2 will be the answer, and that is why you are seeing that 2 is the answer. Let's see the other cases where we have example number 2 here. So let's suppose we have given n equal to 4. So can we say if n is equal to 4, it means the number in the range will be let's call 0 will be there, because 0 contains 0 bit, we can say. if we talk about the 1, it will take 1. Then we have 1 0 for not, let's suppose 2 for 1 0, we can say that. If we talk about the 3, it become what, 1 1, and then the 4, it means it will come 1 0 0. I hope you know this, right? The very first thing is that this 1 0 will be counted and 1 will be counted. Okay, next coming to 1 0, it will not a monobit, right? Then 3 is 1 1, so it's a monobit. Let's talk about the 4 is also a monobit or not? No, because this is 1 and 0 combinations, right? So these are the valid one, right? So if we'll talk about what are the valid one, means this is the valid one, this is the valid one, and this is a valid one, right? So these are the valid monobit numbers, and this is nothing but 0 1 and 3. So total 3 numbers are there, and so we can say the output is matching, right? In case if you have not understood, you can ping me in the comment box, guys, and if you found anything suspicious in understanding or my understanding, please give a comment and report to me. Thank you so much if you are doing that. Let's continue here. So let's go back to the code that we have to understand. So I just want you, right, if n equal to 4, right, so n is given. So very first we know that we have to count it, right? So we'll start from the 1, because count we have to take for the 0, and 0 is a monobit, right? So in val equal to 1, so we'll start with 1, and we'll keep checking the value, count plus plus, and we'll generate the val, and we'll take the left shift with 1 bit, so it will generate 1 3 7 15 like that, and that will go till the n. So val, we basically we are generating the value with the val, and so we can say that we'll return the count here, okay, after making all the counts. So this is what we have in this video, guys, and you know we are taking O of n as a time complexity with respect to the while loop, because we are taking from the 0 to n, we can say, and we should not take anything else here, right? This is a very good approach. It's a greedy approach. So thank you for watching this video, and I'll see you in the next one. In case if you are stuck anywhere, please write in the comment box. Thank you.